All right, ladies and gentlemen, today's topic is tax. And as we go through the lesson today, I want you to focus on trying to see the connections between what we're doing now and what we've done over the last couple weeks. Getting into these last couple topics in percent tax and percent error, which is tomorrow's video, it's more of the same thing, still using the percent proportion and the percent equation just to solve slightly different kinds of questions. So today's date is December 10th, 2013. And the page you should be on is page 78, I think. If that doesn't sound right, guys, let's talk about it in class tomorrow, because I think some of my page numbers might have gotten off, and I want to make sure we're all on the right place. Our objective is that I can use my understanding of percent to solve tax questions in several different ways. I'm going to show you two different ways to solve tax questions, and we're going to talk in class about which way is probably easier. So option one, first, hang on, where did option one go? Sorry, there we go. Option one, calculate the tax. For example, it might be a 9% tax. So you would take 9% of the original price, and then step two, add it or subtract it to or from the original price to get your final answer. That'll make more sense as we go through a problem, I promise. You can use either the percent proportion or the percent equation to solve these. I think by now you know that I think the percent equation is a little bit easier, but if you have been finding that the percent proportion is better for you, that is fine as well. Option two is really just one step long, and it's to calculate the total final price, but you have to use a revised percent, so a percent that you change a little bit. Very similar to what we did in markups and markdowns. So if you really understood markups and markdowns, then this option is probably going to be the one for you. Once again, you can use either the percent proportion or the percent equation. Let's go ahead and jump into a couple examples. We'll put these tax examples on page 79 with the date December 10th. So our first example, a bill at a restaurant is $24.50. You want to leave a 15% tip for the waitress. What do you need to pay? I'm going to turn this into, make a little T chart here. And on one side, I'm going to be doing option one, that you wrote down on the last page, and on the other side I'm going to do option two. So option one says first to find out what the tax is going to be. In this case it's a tip, not a tax, but it's the same principle. So I'm going to find out what 15% of $24.50 would be. How about I do that using the percent proportion? So some fraction is going to equal another fraction. That will be my percent, which should be 15. Remember, is to of, as percent is to 100. So I'm trying to find 15% of $24.50. So that means my variable is going to be right up there. And now I have to take this, cross multiply. I would get 100x equals 15 times 24.50. 15 times 24.50 is actually, hang on, $367.50. That's going to equal our 100x. And then I'm going to solve this using algebra by dividing both sides by 100, giving me x equals $3.675 of a dollar. So I would actually end up rounding this so that it equals 3.68. And that's the tip that you're going to leave for the waitress. Now, as you can see, we're running out of room a little bit, so let's extend our page. The second step for option one is that we then have to add this to our original price. So our original price was $24.50. I'm going to add the 15% tip, which is $3.68. And that is going to end up giving me $28.18, and that's the total cost of the bill. Now, option 2 uses a revised percentage. So at the first step, right here, when you set up the proportion, we are going to use it, we're going to set it up slightly different. We're still going to have X over $24.50. We're still going to have a 100 at the bottom because all percent proportions have that. But instead of doing 15%, I'm going to revise my percent. I'm going to be giving this waitress 100% of the bill plus the 15% tip. So it's going to be 115 over 100. If I were to solve this problem, I would get 100x equals 2,818. When I divide that, because, sorry, I got 2,818 by doing 2450 times 115. If I divide both sides by 100, I end up with x equals $28.18, which is the same problem or the same answer you came up with using option 2. It just has fewer steps. I happen to like fewer steps. Okay, let's do one more quick example. This time I'm going to use the percent proportion. I'm still going to do option 1. Oh, sorry, not the percent proportion, the percent equation. Option 1, option 2. Remember, the percent equation is final equals percent times original. So I get a bonus check from, or you get a bonus check from your employer, and you need to pay 40% of it for taxes. That's how much the government takes away between Social Security and blah, blah, blah. If the check was $450, how much do you actually get to keep? So my final is what I'm looking for. Option 1 says to figure out what percent gets taken for taxes. So that's going to be 0.40 times 450, because that's the original amount that I get, which is going to give us the final tax is $180. But to find out how much you actually get to keep after taxes, remember option 2 has 2 different steps. You have to add or subtract it from the original price. So then I would have to do $450 minus 180, and you end up getting to keep $270 from your bonus check. Now let's look at option 2. Remember, option 2 is all about using a revised percent, and it saves you some steps. So your final price is still going to be the percent times the original, but now instead of thinking of taking 40% and then subtracting that from the original bonus check, I'm going to say, okay, well, I actually get to keep not 40%, but I get to keep 60% of my bonus check, because 100% minus 40 is 60. Remember how I said this was a lot like markups and markdowns? So my final bonus is going to be 0.60 times 450. If you were to put that into a calculator, you would end up with $270. Same answer as you got with option 1. So 2 different ways you can do it. Ladies and gentlemen, this is your reflection. You can do it option 1 or option 2. You can do percent proportion or percent equation. It is up to you. I look forward to reading your responses.